TMA manufacturer 37-inch high definition LCD televisions. Does anyone know what LCDs mean? Not least commonly denominator. LCD TV. You got LCD TV at home? It's pretty good. I looked it up last night, and then it stands for liquid crystal displays. Right. So the point is that it's try to suppress the bad light that come at you when you watch television or do computer and whatnot. So that's what it is. Good for them. So the TMA has two locations, location 1 and location 2. What this company do is that it's gonna deliver TV to a corporation we call the POSA. So this whole company buying television from this company, right? And this TMA has two locations. Location 1 output is at most 6,300 television per month. Location 2 output is 4,700 television per month. In certain month, POSA place order for 2,900 and 3,800 television from TMA to be shipped to the two factory, which is CDA and CDB. So you're gonna distinguish what is what here. TMA has two locations. We call that location 1 and location 2. POSA has two locations. They are in CDA and CDB. All right. So you're gonna distinguish between what CDA, CDB belong to who, and location 1, location 2 belong to who. Right. Now, here this problem we have two sets of variables. But we're not going to do that. We're going to only set up one set of variable, and then we're going to use that to set up another one. Okay, so let me tell you what I meant. First, let me define the variable. Let x, oh, I'm sorry, I haven't finished reading yet. That's one, a tiny bit more here. The table below is the cost function for the shipping. So that's your cost function, which we're going to establish later. TMH will ship X television to location 1. I'm sorry, TMA will ship X television from location 1 to CDA and Y television from location 1 to CDB. So I'm going to say let X, I'm just rewriting this. Let X be, X and Y be numbers of TV. Does anyone want to say television anymore? Maybe older people, but nowadays we say TV. Right? Let XY be the number of TV from location 1 to CDA and CDB respectively. So far so good. Now what about from location 2 to CDA and to CDB? No, we'll take care of that later. Actually by doing this. I'm gonna draw a diagram. So here is location 1. Go to the left a little bit. I have enough space. Should I move down here? Should I? Do I have enough? Yeah, I think I have enough. I don't have to squeeze myself in there. So I have enough space down here. Location 1. I'm gonna ship X TV or TMA gonna ship X TV to CDA, right? That is X. It's not times, that's X. And then they're gonna also ship Y number of TV to CDB. So far, so good. So far, so good. All right. Now, another question is that what is the number of TV they're gonna ship from location 2 to CDA and location 2 to CDB? So down here is location 2. I don't know how many yet. We'll figure it out. Let me ask you a question. How many TV they ship per month? No. How many TV that the posts are buying from TMA per month are being shipped to CD? They're being shipped to CDA to CDB. Posa by 2900, right? To ship to location A, and then another 3800 to ship to CDB. Now 2900, that's from location 1. And then 3800, that's from location 2. So if there's X, I'm sorry. Ah, damn it. I'm sorry. Try, I said it backward. 2900. That is how many TV that they're gonna ship to CDA. And then 3800, that's how many TV they're gonna ship to CDB. Right. Now I know that there's X TV that being shipped to CDA already. How many more left? How many more left? Total is 2800, right? You already take X number of TV from location 1. So there are 29 or 28, 2900 minus X left TV, right? That location 2 had to ship to CDA. Right? Because CDA need what? Need total of 2900, right? They need total of 2900. You don't have to write this one down. And then CDB need total of 3800, right? There are X of them from location 1, so it must be 2900 minus X from location 2 to CDA. Then can someone tell me what should I write here? Yeah. Just gonna try everything. So 3800 minus y, right? Minus y. Let me erase that because I need space later. So far, so good. The reason we do this because we need to establish the cost function. Now the cost function denotes C, traffic repeat. Let's see. From location 1 to CDA, it costs $6 per TV be delivered. How many TV from location 1 to CDA? The X, right? So 6X. Right here is the X from location 1 to CDA, right? So 6 times X. And it costs $4 from location 1 to CDB, and we denote that's Y, so 4Y. Plus, that's 2 more. Plus, location 2 to CDA. How many TV that shipped from location 2 to CDA? 2900 minus X. Okay. Times, what is that? Times $7. And then there are 3800 minus Y from location 2 to CDB times 11. And then you clean that up a little bit. 6X minus 7X, that's minus X. 4Y minus 11Y, that's minus 7Y. The rest on his calculator. $2,900 times 7 plus 3,800 times 11 is 62,100. And that is your cost function. Let me copy it down here. They say minimized function, which is the cost function, equal negative X minus 7Y plus 62,100. One down, a lot more to go. Yes. I hope not. Like I said, I have a good glimpse of what it's gonna be, because what they do is they give you a bunch of problem, and then the people they pick the course leader pick. So I know what's gonna be in the pool. I just don't know like what's gonna be on the exam. Uh, that's why I say I can give you the practice exam. I hope not. I don't think so. I hope not. Uh, for me, I think it would be good with knowing the math department at OU. They're probably gonna do this financer, because most of you are business people or accountant. But let's just cover everything, just in case. All right. But just so far, so are we good? I think the hardest part is to come up with this. Yeah, right. That's the hardest part. The rest is just kind of follow it. Now we finished with the cost function. Now we're gonna move to constraints, inequalities, right? So geez, inequalities. Uh, all right. So we finished with that. We finished with the one I highlight yellow, so we can just ignore that. We also finished with we also finished with this, so we can ignore that. That's just the labeling, defining the x and y. What else? What else? Oh, we haven't finished this one. The output of TV from location one is at most 6,300 television. How many TV being produced in location one? Read your hint. I'll give you a hint. Read this. That's why I write it for. Just keep reminding you the number of TV from each location. How many TV being made in location one or made in location one? That's up to. That's up to. But we don't want to write. We don't want to write up to in English. We're gonna write in terms of x and y. So there's x and y number of TV being made in location one, right? Yeah. I thought I put location one there. Very good. 2 check mark for you. Yeah, x plus y. So that little bit mean x plus y is less than or equal to 6,300. How many TV being made in location two? Oh, come on. You look at the diagram. You can tell me. How many TV being made in location two? 20 and 20, right? And add up had to be what? At most 4,700. So that little bit right there, that means the number of production is location two is 2,900 minus x plus 3,800 minus y had to be less than or equal to 4,700. And then you need to simplify it a little bit. I'm gonna move x and y to the right, so I like to have a positive x, positive y. And then subtract 4,700. This one is 6,000, 4,700. So greater than, no, I'm sorry, that's 67. Oh, 2,000. Okay. 2,000. You can do it slowly, don't do what I do. If I can make a mistake here, you don't want to make a mistake on the final. If you have something like that. So x plus y is greater or equal to 2,000. That's the production of location two. Right? After we simplified that. All right. Almost there. It's actually very easy. The last four is extremely easy. Let's do this one first. Let's do this one first. The number of TV that from location one to CD8. The being shipped to the being shipped. From location one to CD8 is number of TV is X. And since it's, you deliver TV, it has to be a positive number of TV, right? Can be negative. So that's X has to be greater or equal to 0. The number of TV shipping from location 1 to CDB is Y. So Y has to be greater or equal to 0. All right, you should be able to tell me these. Location 2 to CDA, right here. You look at the diagram. Everything is from the diagram. Location 2 to CDA. This. So 2900 minus X has to be positive. And then from location 2 to CDB is 3800 minus Y has to be positive. You can simplify it a little bit if you like. Y less than 3800. Yeah, you can simplify if you like. And I promise you, I'm gonna use decimal to do to solve for this later. I'm not gonna bother solve by hand. If you don't get it now, I wouldn't worry much. You have a chance to do it again in your homework, 6.2 and 6.3. And they have a little video you can watch. So, huh? Well, when you hear second time, it helps. Or third time, it helps. Right? But basically, I got it from the homework. All you do is just change the number. Well, that's why you have to read second time. Yeah, it takes times. When I go in grad school, I like 80% of the time I have no idea what he's talking about. I'm just sitting there, duck there. Especially at U of M, they kind of assume that you know everything. Right? Yeah, first year it was terrible. It was terrible. I like it, but I don't want to come back. All right. Now we've officially done with 6.2, set up the problem. Now we're gonna move on to 6.3, which is solving them. I'm gonna show you how to solve them using calculator. And we're gonna solve with decimal too. Yeah. But before we do that, I like to remind you some terms here. Objective function. Do you guys remember this? It's either the profit function, and we denote that P, or P of xy, or the cost function. We denote C, capital C. Constraints is just inequality. So in the picture, constraint 1, constraint 2, we have 2 constraints here. And then of course you shade, because inequality, you're going to shade your solution. Optimal values. Now, this is optimization problem, right? You're maximizing, minimizing things. So you got to have optimal values. Meaning you're looking for max, if you're looking for profit, or if you're looking for to reduce the cost to be minimum. And it's gonna be given. It's gonna be I don't want to say given. Oh yeah, it's to say given using corner point. What is corner points? It's just a bunch of points that being intersects region. Right there is a corner point. Feasible region is the intersection between two inequalities or more. Kind of like problem 9 on your exam. That's your feasible region. In the book, I think they denote S, and I'm gonna stick with S. If you read some other book, they denote R. It's the same thing. So far, so good. So those are terminology. If I say feasible region, you should know what I'm talking about. Now, how do I solve? If you look at the problem, how do I find my maximum? Think about it. Right? If I give you, well, let me tell you what the theorem first. If a linear programming problem has a solution, meaning you have some kind of region like this, that has some kind of intersection between the inequalities, then the corner points, these corner points, or sometimes they call them vertices, it's gonna give you either minimum or maximum, which just makes sense, right? If I give you a polygon and I ask you to find the maximum and minimum, you look at the corner points, right? Either the highest point or the lowest point. Does that make sense? So it's very intuitive. But let me show you. I'm not going to show you the formal proof. It's way beyond the scope of this class. Well, I'm going to show you the proof that they did in the book. Decimals. Decimals wonderful. Be able to. All right, so here I have a new problem. The profit function is 3x plus 2y. And here the 2's are my constraint. So let me mute that polygon. Bless you. So there's my first constraint, right? And here's my second constraint. As you can see, the solution is the region right there. Let me make it a little bigger. I don't care. I don't care about the first quadrant, by the way. I didn't put the constraint, but only the first quadrant. So what are the corner points? One right here. One right here. Label them 2. And then this one right here, right, 0, 4, and 3, 2, right there. This problem is nice because we can eyeball it. Sometimes with the intercept each other, the fraction, you have to use calculator, which I'll show you how later. So those are 4 corner points, and they're going to tell you the maximum and minimum. Now, how do I know the maximum? Minimum. I'm going to use the profit function. Let me ask you a question. If the graphs of 2 equations are parallel, then their slope must be what? The same, right? The same. The y-intercept doesn't have to be the same unless they kind of lie on top of each other. But why we want to do that, right? We want to see different lines. So the slope is always the same. The only thing different is the y-intercept. So here, if I replace p equal 1, my profit is 1. If you move the 3x to the right, the slope is -3. Same thing here. The slope always -3. But the y-intercept is different. Here 1/2, here is 3, stuff like that. So if I let p equal 1 and I graph that, there's a line. It's the decreasing line because the negative slope. If I graph another line parallel to the orange line, when I let p equal 6, now if I let p equal 10, there's another one, p equal 13. Can you draw a conclusion? What is the relationship between the value of p and the location of the line? They get further and further away from the origin, right? As you increase your p-value, the line is going further and further from the origin. Means what? The furthest line gives you the maximum value, maximum profit. So long story short, the line that furthest away from the origin is going to give you the maximum. The line that closest to the origin will give you the minimum. Okay. Now, why don't I want this line? Why this line is a bad one? It's parallel, so why is bad? Why don't I use? Yeah, it does not intersect the feasible region, right? The line that you graph it has to be in the feasible region, which is infinitely many, but I only represent a few here. So we kind of do not doing that line. All right, that's the explanation. I just had to tell you what behind the scene is. You don't have to remember that on the exam. You can just forget it now. I guess. All right, so that's theorem 1. Now theorem 2. Once you have that, if your problem have a solution and it has a region S, and if S is bounded, what does that mean? It's bounded. Bounded means it's called a polygon. Everything is enclosed. Then it's gonna give you either the minimum or the maximum or both. Give you both. If it unbounded like this one, you can find the minimum, but you cannot see the maximum, right? Because there are infinitely many points. You just kind of go outward to infinity, right? So it's impossible to pinpoint the maximum. But luckily you can do the minimum. There's no maximum. Yeah, you just don't say it. You don't know what is the maximum. Now, if you have no solution, don't write this down. Say that's my two inequality, and they don't intersect, so you have no solution. Then there's nothing you can do. You have no maximum or minimum. Well, I promise you on the exam, if you probably have something like this, more like that. Okay, otherwise, why would they want to ask you a question, right? All right, so all that talk, let me show you the step to solve the linear programming problem. The first step is you graph them, like you did on the exam, the last question. Okay. The second step is, once you graph them, you're gonna find all the corner points. The intersect one is easy, but not the one that they want to intersect each other. And the third step is you evaluate the corner points into the objective function. Could be cost function, or could be profit function. And the last step, I don't know why I repeat this one. Sorry about that. Determine the maximum, the max and min. I say mum, min. That's max and min. Take a look at this one first. I want to know what the maximum and minimum for this problem. So all I do is plug it in. That's pretty it. Plug it in. The first one is 2, 6, 2, 2, 10, 1. I'm going counterclockwise, and then 7, 9. And then you plug into Z. 4 times 2 is 8, minus 6 is 2. 4 times 2 is 8, minus 2 is 6. 10 times 4 is 40, minus 1 is 39. 7 times 4 is 28, minus 9 is 18. So what is my minimum? Yeah, that is my min. Right. So when x is 2, y 6, I have a minimum, and my maximum would be this one. So you got that idea? Why don't you guys try that one? Second one, I'll walk around, see how you do. Does anyone have an extra calculator I can borrow? Thank you, Omar. Thank you. Thank you. Oh, you got a fancy one too.
I got the Amazon recommended.
Huh?
I got the Amazon recommended.
Oh yeah. Oh no, it have like color. The one I have doesn't have a bright screen, so it's kind of difficult to show here. But I think yours fine. Let me try see. Oh, perfect. I don't have to lean toward or backward. Thank you. Thank you. I wonder if I change screen, it will still recording. What's your answer? What is my minimum?
5, 0.
What is maximum? 5, 0? Say 5, 0. All right. All right, so I got 0, 7, 1, 5, 4, 2, 8, 0. All right, 0, 7 is 84. All right, I was just gonna trust you. 1, 5, 66. All right. 8, 4, 2, 8, 0. Put it again. All right. I'm sorry. What is my maximum? I'm sorry, minimum. Yeah, 2 of them, right? 2 of them. Yeah. What is my maximum? Let me ask you again. What is my maximum? There isn't one. None of these are unbounded problems, right? No max. Since it's unbounded. All right. We're gonna do one problem and we call it a day. Okay. We do slowly because we have 3 lectures for these things. We're almost done. Next time you probably leave early too. So I'll walk you through slowly. So we done with that theory part. Now, how do we do that on the problem? Say this one. Where is the furniture problem? All right, let's go back to the very beginning. You remember the furniture problem? I want to solve this. So we set up last time. Now we're gonna solve it. Well, you know how to draw the inequality. So let's draw the first, right? So 40x plus 16y less than or equal to 3,000. My best bet is my t-table. And I'm gonna use x and y intercept. When x equals 0, what's y equal? X equals 0, 3,000 divided by 16, 187.5. When y 0, 3,000 divided by 40, 75. If I was you, I would do this first before I actually do the tick mark. So I know how large I have to go or how small. The second inequality for x by y 580. I'm gonna be lazy. I'm gonna copy and paste this, duplicate this one. Mhm. Let 0 for x 0 for y again. When x 0, y is 580 divided by 5, 116. I'm sorry, can you guys see that? When y 0 is 580 divided by 4. So far, so good. That's just what we did on the exam, right? All right, let's do, let's graph them. All right, so for the y, I need up to 190, right? For the x, I need up to 150. So my tick mark, I'm thinking doing 30 each. Huh? 145, sorry. Let me make it bigger. 45. Yeah, I can. Yeah. It just make it make it orange. Maybe orange. It's just I have to go to that board thing every single time I want to write orange. It's okay. We have time. Thirty, 60, 90, 120, 130, 150. 30, 60, 90, 120, 130. Oh man, I 60, 90, 120, 130, 150. 30, 60, 90, 120. Hang on, let me do this one again. Not better. 30, 60, 90, 120, 150. Oh, because of that, I know it should be 150 here. No wonder I thought at 150 and then it's okay, 180. All right, 187. So roughly here. Doesn't have to be exact, but at least not too far off. Like I don't want to. You put a like a low point right here, it's just way off. And then for the x-intercept is 75. 75 is roughly here. Test point. What should I put for test point? I know you like 0, 0, but you cannot use in this case because why can't I use 0, 0? Like Mimi doesn't go through the line. But why don't I use 0, 0? Because of that. Right? Because of that. It's part of the other line. So I'm gonna use say 30, 30. You put 30 here, 40 times 30 plus 16 times 30. I'm just gonna tell you it's less than 3,000. So we're gonna shade. How come it doesn't, how come it have a skinny thing? It should be fat like that. And then the other one, Why don't you guys do another one? I'll walk around, see how you do. You grab the orange one. Shade it too. $116. Oh, sorry, that's why. And then 145. Ooh, a lot of orange. And then you pick 30, 30. You plug it in here. It's 4 times 30 is 120 plus 150, that's 270. It's still less than 580, so shade this part. So there's your intersection. Feasible solution. All right, corner point. You know what this one is, right? That one is 0, 120. This one is 0. This one is 75, comma 0. Huh? 0, 160. 116. Oh, yeah. Yeah. Sorry, I look at the 120 there. Thank you. Thank you. How do I find this one? I don't know about you, but I'm not gonna do by hand. I'll show you how to do a graphing calculator. Maybe I'll show you how to do both with inequality and give me a second. This new calculator, so I am still figure it out. Maybe all right, so far so good. We're gonna plug into a calculator to figure it out this point right here. Unless you want to do by hand. So before we do that, I gotta solve for y because your calculator is not allow you to just plug in like that. Right, so we're gonna solve for y and we're gonna let it equal. So y equal, move the 40x to the right hand side, so negative 40 divided by the 16 times x plus 3000 divided by 16 again. Do not simplify, it's not worth your times. Right? And then the second one, phi equal negative 4x divided by 5 plus 580 divided by 5. So let me plug in your calculator. Clear whatever you have there. Clear it out. Clear it out. So I have negative. So minus, you're gonna use the opposite key. Okay, do not use this one, otherwise it give you error. So the opposite key, 40 divided by 16. If you want to fancy, you can use alpha and frac if you like, but I'm just gonna keep it simple. Some people don't have that things. Plus parenthesis again, 3000 divided by 16, close parenthesis. We go down there. Second equation. Parenthesis, -4 divided by 5. Plus 580 divided by 5. So far, so good. Now, your calculator, you should have a cursor. You should have it highlighted in the equal sign. If it doesn't, then it won't graph. Right? The highlighter tell you that those the graph they're gonna graph. Hit graph. Oh, it's not good, isn't it? The reason because the window is that, but you probably have the from -10 to 10. So I'm gonna change the window. So min, I'm gonna start my min as 0. My max is, the max for x, if you look at your graph, is 150. The scale, I say 30. Y min 0 again. Y max, I set up at 190. The scale for y is 30 as well. 190. Oh, thank you. 190. And now you graph. No, look at that. You see better, right? It's a better window. So, now how do I find that intersection point? See trace here? Hit trace. Oh, I'm sorry, calculus. I don't want to trace yet. No, I want cal. I'm gonna go to cal. So second trace, because the cal is blue, so it means you have to hit second first. Well, look at the option number 5. So 5, and you're gonna put your little thing right there. It say first curve. Yeah, that one, the blue one. Press enter, and then it asks you want to put the value for second curve. Yes, the second curve is right there. I don't have to move any closer. It's close enough. And I ask you, do you want to guess it? Yes, I do. So there's your intersection. 42, right down here. 42 point, I'm just gonna say 0.1, comma 82.4. Give me a second, okay? I want to know how to graph the inequality. I know how to do it in my calculator, but this one is different. Yeah, that's what I did before, but it didn't show me it. Let me quit. Let me go back to here again. Second test, but 6, but it doesn't. Yeah, it doesn't change. One more time. Second test. Yes, that. But why don't we remove the thing for me? Remove it. I can't. Yeah, I'll figure. I don't know how to do it. I know how to do it in my calculator though. I'll look it up next time. All right, one more thing, and then we're done. We can go. I still be able to let you out early today. Now we have to determine well, this is a profit, so maximum. Zero zero is not help much, but we just kind of put it there. 75, comma 0, 0, 116, 42.1, 82.4. I have my result here. I'll give you the happy ending.
What equation do you use?
P, the profit function. The P right here, 15x plus 80. Yeah, let me. Yeah. How do I do that? Yeah. Come up here. He's gonna be a teacher for a moment. All right. Come around. You can show them. Let me delete that. So
I think it's
apps, and then you go down to inequalities.
Oh,
Ooh, and then I don't know where, and then you go this, and now you can, change it.
you go what do you do?
You go back, hold on, quit, graph,
Mm.
and then you hit the left arrow to get this thing,
Oh, okay.
hit enter, and now you can change this one to whatever you want.
Oh, wow.
Uh-huh.
You
Does
can
that
hear
work?
that? Yeah.
I think it works.
So what? So does it less than or equal to? Is it less than or equal to?
You
I want
change-
less than or equal to. Okay, go
See.
ahead. Put less than or equal to.
listen, that one, right?
That
There
one.
you go.
Press enter.
Enter, and then
Enter
okay.
again.
and
Oh,
then
yay.
graph. Oh, well, on what?
Maybe
what's that?
something. Let me.
Where's the video?
Yeah, it's not hard. You can figure it out at home too.
Right.
But thank you very much. What is the app button?
On the
Oma?
apps. It's right here. Apps.
Oh, okay. App.
You know, app, and then you go
And then
all the way-
7. Okay.
Yep.
And then continue.
Yeah.
Okay. Oh. I
Did it work?
What I did something.
I
I
don't know.
should do that first. I should have moved. Yeah, you're right. Yeah. 7.
I think it's already in the inequalities thing. So
Anyway,
I'm not
yeah.
sure.
But thank you. Yeah, it's. So let me give you the happy ending, and then we can go. Zero, 3, 7, 50, 20, 88, and 35, 85.3. So my maximum is gonna be that's your answer. Yay, we done one problem. That's it for today. We'll continue next time. If nothing else, have a wonderful day, and I'll see you Friday. The last lecture Friday. Well, Mondays we don't have lecture, but that's last class.